In this tutorial, we're going to see how to create this freeze effect using two passes and the screen buffer, plus a deformation texture. We will also use triplanar mapping. This time, I'm going to use a Sketchfab model. You can use any model you like, but preferably with a simple geometry. I'm going to use this model. As you can see, it has several textures and I can achieve an interesting effect. For the animation part, I used Mixamo. The model came with the file animations, but they are not the ones I needed. Finally, I used Blender to compose the animations and clean the model, because I need to add the textures manually. Here we are in Godot. The scene is composed of some elements, that is the model, a plane for the terrain, a particle emitter, and a camera. Finally, a couple of buttons to control the animation. The model has two animations inside the animation player, and these are driven by an animation tree. This has some nodes, a transition node between the animations, and a time scale node to stop the animation. In the parameters of the animation tree, I can change the animation and adjust the time scale. In this GDScript code, the animation is controlled using mainly twins.call methods. These twins are executed with pressing the two buttons. In the bottom part, I also make a twin to modify the parameters of the shader and to obtain a dissolve effect. To achieve this effect, we will use two passes. In the first one, we will simply load the textures that come with the model, and in the second pass, we will use the screen buffer that comes with all the information of the first pass to deform it using a deformation texture that alters the coordinates of the screen texture using the R and G channels. This texture is the result of the deformation, and this another texture represents opaque parts of ice. We are going to use a noise mask to combine these two textures. We will use different coordinate spaces such as screen space, local space, triplanar, and UV space. And we are going to expand the geometry in the direction of the normals in the second pass using the Vertex shader. So let's start by selecting the geometry and assigning a new shader in override material. This time I will use visual shader because we are just going to assign textures. This shader has no complications. I will call it base. Now I will drag and drop the textures. I will start with the ORM texture that combines occlusion, rawness, and metallic. So I will separate the channels using the vector decompose node and assign them to the corresponding channel in the shader. We can see the result. Now we are going to add the diffuse texture that corresponds with albedo. Next, the emission texture, and finally the normal map. Here we have the final result. And now we are going to apply a second shader in the next pass. This time it will be a normal shader because it has more complexity, and I will save it as freeze. Now let's start expanding a little bit the geometry using the vertex section, multiplying by a floating variable that I call volume. I declare the uniform, and now I can expand the geometry. As you can see. The next step is to use the screen buffer to copy the result of the first pass as an image. I just assign it to albedo using the screen UV coordinates. And as you can see, there is an outline around the original geometry because it's getting light and shadow from the environment. I need to disable this using the render mode unshaded. Now, I'm going to load a distortion map that I call refraction, and I am going to declare a couple of variables to control it: refraction scale and refraction strength. Now, I'm going to load the deformation texture with the scale variable, obtaining just the red and green channels because they are the only ones that the deformation texture has. I multiply by 2 and subtract 1 to obtain positive and negative values. Now I apply the distortion vector to the screen coordinates, multiplying by refraction strength. The screen texture is just shifting because I haven't loaded the deformation texture yet. Now that I apply it, you can see the deformation that it does on the screen texture. I am going to use the Remap function to adjust the refraction strength variable since it requires very small values. For this I create a new shader include and call it funcs. Here I will copy the two functions I need since Remap depends on the first one. Remap comes by default in Visual Shader. You can copy the code from there or use this one. I include the file. Now, I use the remap function to accept an input of 0 to 1 in refraction strength and get an output of 0 to 0.05. Now it's more functional and I can adjust better the effect. Now, I will assign the previous refraction result to a variable called deformation, and I will create a new variable called ice, which gets the color of a texture. I also create the variable uniform and a floating variable, ice scale, to control the size. Now, as you can see, the texture looks clipped because we are using the UV space, but since we are going to use noise mask for this effect, won't be noticeable. Now, we are going to use the noise mask, and for the moment I am going to use the UV coordinates so you can see the result. I create the uniform variable. I assign the result to albedo and I load the texture. As you can see, the UV coordinate space is completely useless in this case, so we have to look for another option. I will assign the most appropriate value for the noise scale, and I will also create a noise scale variable to have a more precise control over the size. Now, what I am going to do is to use a local coordinate space using the triplanar mapping technique. It's a well-known technique in all game engines where the different coordinate planes are used to load a texture. As its name suggests, there are only three planes where we can load the same texture or different textures. In this case, I am going to use the same texture 3 times. It's important to do it this way so we have a smooth interpolation. Now, I am going to use a triplanar function with the same texture using noise scale and interpolation value. Here we notice again the crop effect, but this time is due to the fact that I didn't set the noise texture as seamless. So I adjust that value and I am going to change the texture size. Now it works better. Now, there is a small problem with triplanar mapping and models that contain vertex animation using bones, and that is that triplanar mapping remains static and doesn't follow the movement of the vertices, which makes sense because triplanar mapping is based on the transformation of the object and not on the vertices, which is the case with UV mapping, and that is its main advantage. But in this particular case, it doesn't matter because it's supposed to be a freeze effect and the model has to stop its animation, so at the moment of the transition is made, the texture movement is no longer noticeable. Finally, we're going to mix the two textures using the noise mask, but as we can see, the effect is not as expected. So I am going to modify the mask with smooth tip so that the deformation texture is more visible. I have to invert the textures in the mix, and now it looks much better. I adjust a little bit the parameters, and I will use the world environment node and a texture to improve the color of the effect. I will also assign a couple of textures to the terrain for albedo and the normal map. And I will change the scale a little bit. Finally, for the dissolve effect, I am going to use the alpha channel. The problem is that when decreasing the opacity, it seems that the object moves. So I have to animate the refraction strength at the same time. I do this in GDScript. And this is the end.